All right, so 3.1, quadratic functions and models. So what is a quadratic function? A quadratic function is any function that has basically a degree of 2. So that's the biggest degree of 2, okay? So for example, a quadratic function is what you would use to graph a parabola. A parabola is the graph of a quadratic function. And I used this form. There are different forms for quadratic functions, but this is f of x equals ax squared plus bx plus c. So we usually see it in this form, right? Like 5x squared plus 2x minus 1 or whatever. So that is a quadratic function. Okay, parabolas, what do they look like? They look like U's or N's. They either go up or down. Sometimes they go to the left or right, but then it's not a function. It's just a parabola. So they usually look something like that, or they go upside down, right? And they always have a vertex. So the vertex is going to be the very bottom, the minimum, or the very top of that parabola. How do you get the vertex if you have this equation given to you? You do negative b over 2a to get the x-intercept. How do you get the y value? Or not the x-intercept, sorry, to get the x value of the vertex. How do you get the y value? You plug this, whatever it is, back in to x, and then you get the y value. So plug it back in to get the y value. All right, and then there's always this axis of symmetry. So I drew it over here. Axis of symmetry because a parabola is symmetric on the left and right side. So the axis of symmetry always goes through the vertex, and because it's a vertical line, the equation would be x equals, what does it go through? That value. So x equals negative b over 2a. Okay, and then the next part is going to be, so we're going to like start with this stuff and then later we'll put it more together, okay? So then the next part is talking about the discriminant. The discriminant is what goes under the radical when you have the quadratic formula. So what went under the radical, we think back, was b squared minus 4ac. And again, that's the part that goes inside the radical of the quadratic formula. Okay, well, I'm going to start writing on my papers. The quadratic formula, remember what it is. So it's x equals, and then there's a little song that goes with it, x equals negative b plus or minus square root b squared minus 4ac all over 2a. So there's our little formula, right? There's a story that goes along with it. I told you in class, but I'm not going to say it again. So we have to remember the quadratic formula. Okay, look at this. The quadratic formula gives you, yes, the determinant. Yes, that is true. We'll talk about why that's important in a bit. But also, look at the stuff outside of the determinant. Negative b over 2a, that's your vertex. If you have negative b over 2a, x equals negative b over 2a plus or minus the determinant inside a radical over 2a, technically, right? So it's plus or minus some value. So why would it be plus or minus? Because now this is the middle, and then we're adding and subtracting to get some other x value and y value, and it's plus or minus the same thing, which is why this is our axis of symmetry. It's symmetrical. It's the same on the left and the right, because that value is just the same going up and down the x-axis. Okay, so this tells us a lot of information. Okay, if the determinant, the highlighted part, is positive. So let's say that highlighted part, so I'm going to write the whole like plus or minus radical. Let's say that's positive. So that would just be plus or minus 2, right? So you're adding and subtracting 2. Okay, 2 is a real number. So if the determinant is positive, so greater than 0, then what you end up with is 2 real roots. What are roots? They're called zeros, they're called solutions, they're called x-intercepts, because when you graph a parabola, that's what you find. Your 2 real roots are literally your x-intercepts. So it might look something like this. It could be a parabola going down, but it's still going to cross the x-axis twice. 2 real roots. Okay. What if you have equal to 0. So if the discriminant equals 0, let's think about that again. If the discriminant equals 0, if this equals 0, then do you have a plus or minus number? No, you don't have a plus or minus. That's why you end up with one real root, because it's just plus or minus 0. That's what one real root looks like. It crosses the x-axis one time. It barely touches it. Or maybe it goes down, but it touches it right at the vertex. Okay? Okay, what about our last scenario? What if this was a negative? What if that was a negative on the inside? The determinant is a negative, then what would you get here? You would still get a plus or minus. You would still get a 2, but now that -1 is an imaginary number, so now you would get plus or minus 2i. You would get 0 real roots, but you would still get 2 imaginary roots. And when you draw the parabola, if you draw the parabola, this is what you would see. You would see the parabola, if it's facing up, it'd be floating above the x-axis. If it's facing down, it would be floating below the x-axis. It would never touch. That's why you have imaginary roots. Okay, so we're gonna start doing some examples that don't really talk about this stuff, but it's still review. And then we're gonna kind of go back to this, okay? So example 1, and I wrote a little bit too much on here already, but that's okay. Determine the quadratic function that satisfies, and it gives you a vertex, and it gives you a point on the parabola. So what I did is I said, well, a vertex is hk, and a point, any random point is 0, 5 is xy, okay? So I filled in with my pencil an hk and an xy. The reason I wanted to do that is because I knew that I wanted, eventually, I have this information, it would really help if I used vertex form. Instead of standard form of a quadratic function, this is called standard form, I use vertex form because they give me a vertex. So it's much easier to use this. Okay, this has 1, 2, 3, 4, 5 variables. I actually am given 1, 2, 3, 4 variables. So what you can literally do is plug it in and solve for A. So you just go ahead and plug it in. Don't copy me. Just plug it in. Solve for A. And then once you find A, that is not the final answer. Your answer is a quadratic function. And then you can just put it in that form, right? Y equals a number times x, and then plus or minus something, and then squared, and then you have that -7 at the end. Okay? So here is our final answer for quadratic function. Okay, so another example. So this example might be different depending on the class you're in, but I decided to change it up a little bit. So let's say you have 3,000 feet of fencing available to enclose a rectangular field with a river on one side. If there's a river on one side, what is the largest area possible? So you have this much fencing. You want to fence in as many, I don't know, cows as possible or whatever. So you want the largest area. You want to know how long each side should be. Okay, so first what you're going to do is you're going to draw a picture. So I'm going to draw it on here. I'm going to draw myself a picture. And then I have 3 sides of fencing because one side is my river. Okay, so first I'm going to use logic and then I'll show you without logic, okay? So first, let's say this is x. Well, then this would have to be x. What would this be? Well, I have 3,000 feet total, so 3,000 minus 2x. Literally, it's 3,000 minus 2x. How can I check this to make sure it's right? I literally add this all together. If I add this all together, I get 2x plus 3,000 minus 2x, which is 3,000. I have 3,000 feet total. There you go. I checked my answer. Here is another way that you can think of it, where you have, so let's say you couldn't find these numbers, okay? So then you think about it and you go, okay, the perimeter of this figure has 2 widths and 1 length. If you solve for the length and you plug in 3,000 for the perimeter, you get 3,000 minus 2w. So you would get a w, and then 3,000 minus 2w. So if you don't want to just think about it in your head and use logic, you can solve it mathematically for each side. So you can do it that way too, like a W, and a 3000 minus 2W. So that works as well. Okay, I want to show you ooh, just kidding, I don't have the other example. So we're going to keep with this example. All right, largest area is the area of a rectangle. Area is length times width. So I just start off with that. And then I go, okay, well this one, I would have to multiply those two sides. So in terms of x, I would multiply my width and my length. And then if I were going to multiply it out, I get this. And then if I were going to put it in the right order, I get this. Do I have to do this? Not necessarily, but I want you to realize something. So looking at this is a parabola, and it goes, you tell me, up or down. So this is a parabola with a negative in front, so it is a downward facing parabola. If it is a downward facing parabola, that means that there must be a maximum. That makes sense because I'm finding the largest area, which is a maximum area. So I'm really looking for the vertex. I'm looking for where A is biggest. How do you find a vertex? Well, how do you find a vertex? So negative b over 2a to find your x value, and then plug it in to get your y value, right? So I wrote x, so that, well, yeah, it's supposed to be x, and then plug it back into here to get your y value. You can plug it into here, you can plug it into here, you can plug it into here. You're going to get the same thing. They're all equal, right? So then you just remember, oh, I have to, label my answer. This is in feet. I'm finding an area. This is feet squared. Done. Okay, so then our last piece. So flipping it to the back, and we are going to talk about how to graph a parabola. So to graph a parabola, you can do one of three things. The first one is my favorite because it's usually the fastest and the easiest. You guys know how to factor, so you factor and solve. That gives you x-intercepts. If you have two x-intercepts, you just find the middle, and then you find the vertex. And then you have 3 points. You graph the 3 points, you're all good to go. All right? The second one is my least favorite. I would never do this, but I'm going to write it down anyway. So the second one is you can, instead of factoring, you can use the quadratic formula, and then you would do the same thing. You would find, hopefully, 2 answers, and then you'd graph them onto the x-intercepts, the x-axis, and then you have a vertex in the middle, and then you find that vertex. Okay, so 3 points, done. So sometimes something's not factorable, or sometimes you factor and you get like x minus 2 quantity squared. That's not going to help you, right? So instead, this will always work. So if you put your equation into vertex form instead of factoring, it will actually always work, but it takes a little bit more time. So factoring is the easiest if you can factor. So vertex form takes a little bit more time because you have to complete the square. And then you're using some sort of transformations, or you can use a t-chart or whatever, okay? Because even though it says transform, I mean, really, you can just graph it however you want to graph it, all right? We don't have to like be so perfect. We only need a couple points, right? It's a parabola. It's not crazy looking. Okay, so let's try this one. So this one is very specific. It says graph using transformations. I didn't actually do that, I'm going to be honest. But I did use vertex form, and then I'll remind you how to graph with transformations when we get done with it, okay? So graph using transformations, we have to start by completing the square. So you have to get it into vertex form no matter what. So sometimes I'll ask you like, what is equivalent to this? And then you'll have to choose the right answer or whatever. So or I'll say like, what is the vertex form? And then you'll have to find the vertex form, okay, without even graphing. All right, so the first step is going to be, I'm going to do this on my regular paper, actually. And then you guys can, write it over here. So the first step is y equals 3x squared plus 6x plus 1. That doesn't look like it equals. I'm going to fix it. Okay. So a lot of people say, I want to subtract 1 to the other side. That's not wrong, but I'm not going to do that because technically I want to leave the left side by itself because in the end I want it to say y equals. So my first step is going to be, when you look at this, see how the x is by itself? There's nothing in front of the x except for a 1. So I want to factor out the 3. That's actually my a. That's going to be my a. So 3 times, and then I have x squared plus 6 divided by 3 is 2 Okay, don't do this one. Don't divide 1 by 3. That's crazy business. So instead, you're going to put plus blank. And then this 1 over here, I'm going to put over here. So I still have my 1. I still have my 6, which is 2 times 3. I still have my 3. Okay? So now I have a plus blank because I'm trying to complete the square. I'm trying to make a perfect square trinomial. Okay, I'll remind you what that looks like. So because I'm adding a random number here, I would normally add it to the left side as well. But I don't want to touch the left side. So instead of adding it to the other side, I'm going to subtract it from the same side. But because this is getting multiplied by 3, I'm going to put a 3 here just so I don't forget. Okay? So that blank, I'm going to subtract here as well. Whatever I add, I'm going to subtract so it's still like, the equation's still equal. Okay, so in my next step, y equals 3 times quantity squared. And then I think about, okay, what should go here? So if you don't remember, you can do it 2 ways. If you don't remember, the easiest way to do it is you look over here and you go, okay, this is going to be x plus, because it's x squared plus. So this is going to be x plus, and then you take that number, divide by 2. And then it should look familiar, like, yeah, if I were to square this, yes, I would get this. That makes sense, right? If you square this. But then what you do is really you divide by 2, write down the number, and then you square that to get that. So if I square it, I go back in, and I have my 1, and then I put my 1 here too. Whatever I write here, I write here. Okay, and then what is that? 1 minus 3, so negative 2. This is my answer if I'm just completing the square and getting vertex form. So this would be vertex form, which means that my vertex is negative 1 comma negative 2, because remember x is, x is y. So really the one next to the x is a liar. So negative 1 comma negative 2. And then you can do this a couple different ways. It says to use transformations. I'm going to remind you what it looks like when you use transformations, okay? So if you're using transformations, then this started off with, this is the parent function, y equals x squared, all right? And then what happened to it? Number 1, it's been a long time. This is a vertical stretch of 3y. Number 2, what is that? That is a horizontal shift of x minus 1. And number 3, that is a vertical shift of y minus 2. And then when I do my little xy's, I'll do it over here just because there's space. So xy, I start with this, and I go 0, 1, 2, and then negative 1, negative 2. I square them, and then I do step 1. So this says times 3. All right, so 12, 3, 0, 3, 12. So I did this. And then it says minus 1. Okay, so negative 3, negative 2, negative 1, 0, 1. So I did this step. And this says minus 2. So all my verticals, I minus 2. So 10, 1, negative 2, 1, 10. These are my y values. These are my x values. But because once I get my vertex, it's a little bit faster if I just plug in. You can use transformations. I just reminded you how. You just graph this. You can also, once you get your vertex, go ahead and do a little t-chart. You know this goes in the middle, and then you just go down 2 and up 2. Go ahead and plug in these two very, very carefully, the 0 and the 1. Plug it into here, plug it into here, it doesn't matter. And then if you plug it in very carefully, you can just reflect it onto the other side. And then you go ahead and draw it. If you're using line paper, you're going to draw as neat as possible. See how mine's even not so neat? Like my parabola is a little bit, I had to like refine my point, make it bigger, right? That's okay. So as long as it looks pretty good and pretty neat and all your x values are equal tick marks and all your y values are equal tick marks. Notice how I went by 2's on the y's, because otherwise it's like way too way too vertical, right? It goes up and down way too high and way too low. So I went by twos, but as long as those are all equal and you go by twos for each one, it's okay. So if you're using line paper, that's fine. But if you are messy at all, then please use graph paper instead. Okay, but I'm okay with line paper for parabolas because technically, we're going to be honest, technically 3 points is enough. For a parabola, technically 3 points is really enough. We're good with that. And that's why up here, I said graph the x-intercepts and a vertex because this is 2 points usually and this is 1 point. So you end up with 3 points and that's good. All right, so there's 3.1. Good luck. See you later.